This is A2Pure Math, and it's just a quick video on integrating cos squared and sine squared. The deal is if you're integrating powers of trig functions, it gets a wee bit complicated. Integration can't quite deal with it in that way, so we need to rearrange and set it up in a different format. If you want to integrate, let's go for sine squared x dx. As I say, integrating trig powers is complicated, so we need to do a wee cheat where we use the double angle formula for cos and rearrange it, and then it's easier to integrate. So if I rearrange this one, hopefully you can see if I take the 2 sine squared into this side, sine squared a, and then that's going to equal a half, take away a half cos 2a. So I'm able to change a trig power into a trig double angle, and double angles and treble angles and that sort of thing are much more straightforward then to integrate than powers of trig. So I can rewrite this then as the integral of a half minus a half cos 2x dx, and now we can go ahead then and integrate it. So I integrate a half, I'm obviously going to get a half x. And what about integrating minus cos? So if I remember, if I differentiate sine, I get cos. So if I'm integrating cos, I get a straight sine. That means the minus is going to stay. And then if I was differentiating, how's your memory for this? If you're differentiating something like sine 2x, you end up with 2 cos 2x. So I tend to remember then, if it's a double angle formula and you're integrating, then you're dividing them by that 2 rather than multiplying. So it's going to then be minus a quarter sine 2x plus c. So that's how you would integrate sine squared. Integrating cos squared is pretty similar. Again, I would use this double angle formula here. Of course you can't see it. So I want to get the cos squared bit on its own. So I would rearrange, I'll keep the cos squared over here just so you can kind of see it. Cos squared a, so you're adding 1 to both sides and then dividing by 2. So it's going to be a half cos 2a plus a half. So I can rewrite this as the integral of a half cos 2a plus a half, no I can't, cos 2x obviously. So now I can go ahead and integrate this. So if I differentiate sine, I get cos. So if I am integrating cos, I get sine. And it's going to be, as we just said in the previous one, a quarter sine 2x plus a half x plus c. In the next video we'll do kind of higher powers of trig functions. Again, it's a wee bit complicated, so you can't do powers of trig functions, so you need to rewrite it in a different format and then work it from there.